Hello students, welcome back to this lecture series of M.Sc. Part 1 Physics, Mathematical Methods in Physics. In the last class we discussed about orthogonality, property of Bessel functions and generating functions and some regression formula. So today we are going to solve some example by using the regression formula. Okay. So first example, prove that j prime 2 x is equal to 1 minus 4 by x square into j naught x plus 2 by x into j1 function of x. Okay, this is a given examples. Here is 1 and here is 0. Okay. So this is given examples. We are going to solve this by using the regression formula. So we know the first regression formula and the second regression formula. So here I am going to use the first and second regression formula. Let's start. So we know the second regression formula, that is x into j prime in function of x is equal to minus n into jn x plus x into jn minus 1. Okay, this is the second regression formula. So in this formula, if I put n is equal to 2, okay, from this given example, so it is x into j prime 2 x is equal to minus 2 into j2 x plus x j2 minus 1. So this will be the j1. Okay, and from this we can find j2 prime x is equal to minus 2 by x into j2 x plus j1. Okay, this is equation number first. Okay, so we have the now j prime 2 x is equal to minus 2 by x into j2 plus j1s. Okay, this expression for the j prime 2. Okay, now we know the second or first regression formula, that is x j prime n x is equal to n into jn x minus x into jn plus 1. Okay, this is first regression formula. Okay, so from the first and the second regression formula, if you observe, x j prime n x is equal to minus n jn x plus x into jn minus 1, and this is a first. So this left hand side of these two formulas is equal, so we can equate this two regression formula, that is like this: minus n jn x plus x jn minus 1 is equal to n jn x minus x jn plus 1. Okay, from the regression formula first and second. Okay, so here I am going to put n is equal to 1, so these expressions become minus j1 function of x plus x into j1 minus 1, so it is j naught is equal to 1 j1 function of x minus x into j2. Okay, so from this we can find j2. So for that j minus j1 plus x j naught is equal to minus x into j2. Okay, and if I multiply, so it is 2j1 minus divided by x minus j naught is equal to j2. Okay, so for the j2 we have the expressions, these things. Okay, j2 is equal to 2j1 by x minus j naught. Okay, so if you observe here, j prime 2 is equal to minus 2 by x into j2 x plus j1. Okay, so here these things I am going to replace from the equation number second. This is equation number second. Okay, so j prime 2 x is equal to minus 2 by x. Now j2 replaced from the equation number 2, so it is 2j1 by x minus j naught and the plus j1. Okay, so it is minus 4j1 by x plus 2j naught by x, sorry, here is x square and plus j. And if I take out the common j1 from this first and the third term, so it is 1 minus 4 by x square into j1 plus 2 by x into j naught. Okay, so this is j2 primes j prime to x. Okay, so this is a solution of this given example. Okay, now let's discuss the second example using the regression relations, so that 4j double prime n is equal to j n minus 2 function of x minus 2 j n x plus j n plus 1 function of x. Okay, so here is a 2. Okay, so this is a given example. 4j double prime n x is equal to j n minus 2 minus 2 j n plus j n plus 2. Okay, so here I am going to use the third regression formula, that is solutions 2 j n prime j prime n x is equal to j n minus 1 minus j n plus 1. This is a third regression formula. Okay, so by using this formula we are going to solve these examples. Okay, so if I differentiate these things with respect to the x, so differentiate regression formula third, okay, with respect to x. So we know this basal functions, that is j prime nx is a function of x. Okay, so we can differentiate to, so if I differentiate to, it is 2j double prime n, the function of x is equal to j prime n minus 1 minus j prime n plus 1. Okay, this is first equations. Okay, okay, now if I replace the n with the n plus 1 in the recursion formula's third, okay, so expressions becomes 2j prime n. Now n replaced with the n plus 1, so it is 2j prime n plus 1 is equal to j n plus 1 minus 1 minus j n plus 1 plus 1, okay, from the recursion formula thirds. Okay, n replaced with the n plus 1. Okay, so this thing is equal to 2j prime n plus 1 is equal to j n minus j n plus 2. Okay, and j prime n plus 1 is equal to j n by 2 minus j n plus 2 by 2. Okay, this is expression for the j prime n plus 1. Okay, so this is equation number second. Now, okay, now I replace n with the n minus 1. Okay, in the recursion formula third. Okay. So if I replace n with the n minus 1, so it is 2j prime n minus 1, the function of x is equal to j n minus 1 minus 1 minus j n minus 1 plus 1. Okay. So this expressions implies j prime n minus 1 is equal to j n minus 2 n minus 2 minus j naught. Okay, so this is equation number third. J prime n minus 1 is equal to j n minus 2, sorry, it is divided by 2. Okay, so from this steps, if I write j prime n minus 1 is equal to j n minus 2 divided by 2 minus j n divided by 2. Okay, this is equation number third. Now from the equation number second and equation number third, if I replace these things, j prime n minus 1 from the equation number third and the j prime n plus 1 from the equation number second, so here. Okay, from equations second and third, substituting third and second in equation 1. Okay, put the equations third and second in the equation number 1. Okay, so it is 2j double prime n x is equal to, from equation number first. Okay, so j prime n minus 1, that is equal to these things, so it is j n minus 2 divided by 2 minus j n by 2 minus bracket now j prime n plus 2 from the equation number second. Okay, so it is jn by 2 minus jn plus 2 divided by 2. Okay. So if I multiply with the 2, so it is 4j double prime in 4j double prime in the function of x and jn minus 2 minus 2jn plus jn plus 2. Okay. So this is the solutions of this given example. Okay. If you observe what they given these things, jn minus 2, this j is a function of always function of the x. Okay, so I am not right in the right hand side. Okay, so jn minus 2 the function of x minus 2jn plus jn plus 2. Okay, okay, so let's discuss next one. Question number, okay, problem. So third, so that d by dx into jn square plus jn plus 1 square is equal to 2 into n by x into jn square minus n plus 1 divided by x into jn plus 1 square. Okay, this is a given examples. Okay, so here I am going to use the two first and second recursion formula, that is solutions x j prime n x. Okay, first recursion formula is equal to n jn minus x jn minus jn plus 1. Okay, plus minus plus. Okay, first recursion formula, and we know the second one, j prime n x is equal to minus n jn plus x jn minus 1. This is second recursion formula. Okay, so by using these two formulas we try to solve these things. Okay, so from this left hand side of this examples or given problems, that is d by dx is equal into d by dx into jn square plus jn square plus 1. If I differentiate this thing, so it is 2jn into jn prime plus 2 okay, jn plus 1 into j prime n plus 1. Okay, 2. Okay, if I differentiate with respect to the x, because this jn is a polynomial, a Bessel polynomial functions. Okay, so if I differentiate with respect to x, so this expressions we can find. Okay, after the differentiate with respect to the x. Okay, jn square, so this is 2jn into, here is into j prime n plus, for this, that is 2jn plus 1 into j prime n plus 1. Okay, so from this recursion formula first and second, we can write from recursion formula first and second. Okay, so j prime nx is equal to n into jn by x minus jn plus 1. Okay, this is j prime nx is equal to njn by x and minus jn plus 1 jn plus 1, and from the second one, that is j prime nx is equal to minus n jn by x plus jn minus 1. Okay, this what we have the expression for the j prime in x and the j prime in x. Okay, here. Okay, so these things I replace with this from what we find the j from the regression formula, what we find the j prime in x. Okay, and try to solve. Okay, so something. Okay, here one thinks that is if I replace this n with the n plus 1, so it is j prime n plus 1 is a function of x is equal to minus n plus 1 divided by x j n plus 1 plus j n minus n plus 1 minus 1, so it is j n. Okay, these things. So now we have the expressions. Suppose this is equation number first and this is equation number second. Okay, so from equation number 1 and the equation number second, j prime n and the j prime n plus 1s, if I substitute here, okay, j prime n and the j prime n plus 1, so we can find these relations. Okay, let's try. So it is 2, take out this commons, or okay, 2 jn and j primes from the equation number first, so it is n into jn by x minus jn plus 1 plus 2 jn plus 1. Now j prime n plus 1 from the equation number second, so it is minus n plus 1 divided by x into jn plus 1 plus jn. Okay, bracket. Okay, so 2 take out. Okay, 2 jn square into n by x minus 2 jn into jn plus 1 plus 2 jn plus 1 and minus n plus 1 by x, and here is a square. This if I multiply, so j square n plus 1, and this thing is a plus 2 jn plus 1 into jn. So these things and this thing will be cancel out, and you have 2 jn square into n by x plus 2 j square n plus 1 minus n plus 1 divided by x. Okay, these things. So if I from this take out the common, that is 2. If I take out common 2 into n by x into j square n plus, or here is a minus n plus 1 divided by x into j square n plus 1. Okay. So this is what we have the result. We want a result from the given examples. Okay, so d by dx, okay, this is equal to d by dx is equal to d by dx into jn square plus j square n plus 1 is equal to 2 n by x j n square minus n plus 1 x into j square n plus 1. Okay, this is what we have the result. Okay, so let's stop here. We will discuss in the next lecture. Okay.